Yo, what's going on, guys? Welcome back to another TNT action video, and this one will be a little bit different. Before I start, I just want to say it's been a while since I've made a video for this channel or any channel that is other than TNT Gamer. So, yeah, this is a site where you can learn to build or learn about electrical components. And I will put a link to the site in the description below. It's also an Android app. You can find it on Play Store. Just type up every circuit, and you do need to buy some of it to get certain simulations and components. You could also sign up. So yeah, so for this video I'm just going to show how a power supply is built. I don't know the exact frequency just run at, because a lot of electronics have multiple stuff beneath it. If you get one simple thing wrong, like the amps or the frequency, guys, it for your circuit, it could damage very easily. So these things take time to learn. And because I know how to build a lot of it doesn't make me smart in it. I keep saying that to people. Yeah, they're saying I'm really smart in it, but I am not. I mean, I appreciate it, but seriously. If I was smart in it, I would have been able to take out all those components from the circuit boards and keep them neatly. I don't, so I keep them on the circuit boards to stay in place in case I need it. But now I need a soldering iron to know how to buy a new one. Anyways, yeah, forget about that. So yeah, inverter, not inverter, power supply. Power supply is basically an electronic where you plug on to either like 125 volts or 250 volts, 300 volts, high voltage basically, and you convert it lower to safely use to power your little electronics like phones, laptops, anything. So a power supply could be a phone adapter, a laptop charger, a battery, but battery stores power. I'm looking for something that converts it. So yeah, so that's what I'm going to do. So first things first, hopefully I don't lag. I'm going to take a power supply here, which I don't need. Fine. We need we need current, not voltage. Voltage and current is two different things. So let me just adjust this. There you go. Let me set this to say 200. Let me set this to a lot of volt. Too much, too much. That should be good. I will set amplitude to like say let's set it to 5 volts. Good. Now we need to see if we can convert this. For example, where's bulb? I don't remember what the bulb looks like. Hold on. We look for bulb. Okay, found it. I found a lamp. This should work. So look what happens when I connect these two. Where's the switch? Where's the switch? Where's the switch? Push button switch. I'll use this. Let me just rotate this. What just happened? Did I delete it? Rotate. Rotate. Wait. Rotate. What? Screw it. I'll just delete this one and put this on top here. Why can't I? Okay, let's connect here. Nice. So, if we set this, oops. If we set this lamp, so you see how much volts this is. Okay, this lamp requires 1.5 volts in order to work. Anything higher than that will start to damage it, or anything much higher will instantly kill it. So 1.5 volts. Let's start the simulation and see what happens. So if I press on this button, Um, Wait, how do I turn on? I only know this on Android. How do I turn on the thingy? Give me a minute. Okay, there we go. We had a simulation running, so you could see there's current going through here, but not fully because the button is closed. So if I hit this, you could see, boom, it destroyed. So how do we fix this? Instead of just lowering this, because obviously you can't just lower it, so you need something like, you need something to reduce the current, convert it to AC current, slash DC current, anyone, and you rectify to stabilize the current flow, and voltage select, polarized selector, something like that, negative or positive. So you have to direct it. So for that, we're going to have to make one. So what I'm going to do, I'm going to get, let me just stop the simulation real quick. Okay, so I'm going to delete this. Delete this. Can I not delete this? Oh, it's lagging. Everything froze. Okay, so I had to run this from a phone because the entire computer just froze for some reason. And yeah, so we was going to make something to convert the current to safely use on a little 1.5 volt bulb. So yeah, first off, let me just get back this current. Let's rotate this. It's easier. It's a little bit easier to use. So we set this back to the voltage we used. That'll be about that much. So this destroy this volt up to this voltage destroy the thing. Oops. Noise. So we need something to ground, not ground, sorry, something to convert this. So what we're going to need is a transformer, and in my next video I will make a video on that. But do I have a transformer? Yeah, I do have a transformer for that. Yeah, make a video on that probably later or tomorrow. Sorry for my voice crack. It's early morning. Okay, so we need transformer here. We have to edit this. So for the primary turns is the output for us. So how much turns we're going to have on the output power. We're going to set 60. We're going to set it to like, oops, that's too much. Yeah, we'll set it to 60. Secondary turns will be, say, okay. We can set it, yeah, that will be enough since it's 120 something volts current. Okay. So we're going to rotate this, rotate, 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 noise. Now connect this, and then rotate the ground. Connect you here. Nice. Okay. So now we have that there, but it's still not stabilized properly. So how we're going to stabilize this is a full bridge rectifier. Now you can buy these easily somewhere, but you could also make it if you don't have one to buy or anywhere else. So how to make this? You're going to need a diode. Diode is a component that allows for, current flow through one direction but stops it from going back. Where is you? Am I blind? Is this? Yeah, that's it. I'm blind. So let's um I'm gonna have to get multiple of these. Not this one. Not that one. Okay, so Jesus Christ. I put these facing each other. I'm so confused. Is this not diodes? Yeah, that's diodes. Then why isn't it working properly? It's a light emitting diode. Maybe these are just how far it could go. That's okay. You can set it far. So copy what I doing. Like I said, tomorrow I'll make a video, or probably later I'll make a video on how to make a converter, a power supply. So let's put this one easier. Noise. Nice. So all these diodes is connected. I'm gonna make sure these things spaced out properly. Is that spaced out? I can't put them too close. It wouldn't work. Let me put this there. This looking normal. Okay. So now we're going to need a capacitor. Wait, let me switch up something real quick. Okay. So the AC current goes here. But just move these lines a little bit. That's not what I wanted to do. That's okay. Move this a little bit so. So this just delete this, connect this to this. Okay, it's still connected. So both of these the output of the transformer is now stabilized, but now we need a voltage selector, and for that we need a polarized capacitor. Polarized capacitor is basically a kind of capacitor which is made in a way you cannot connect it backwards, otherwise it will heat up and explode, and any voltage over it, backwards or front, will blow it up. So yeah. So let me just look for the capacitor. Yes. So I believe the negative goes out here. Oh yeah. Can it fit here? No? Wait. Just move this a bit. Nice. So the negative goes, let me turn this here, there. So if I click play, oh. We're talking about circuits are better animated. What? Okay, I have to use a different app simulator for this one. Okay. So this is basically the same thing. You can see the rectifier, you can see the capacitors, you can see the highlighted blue one is the capacitor. So if I just take this and connect this there, we just stop, reset, play, there you go. You can see the voltage is flowing through. So now let me look for a light bulb or something. There you go. Now let me see the rating of it. Rated 80. Okay. Let me set this to like a let's set this to 6 volts. Rated voltage 8 volts. Save. Also have a voltmeter here so I could know how much volts again. So all we need to do is rotate. Nice. Connect you. I want to connect this, we'll know. So there is 7 volts, this is rated 6 volts I believe. So if you connect this here, boom, easy bulb, and it works. But what would happen if I disconnect this? You might be wondering why it took so long for the current to stop flowing. Ignore the bulb. The bulb is just there. So look how long the voltage power on the capacitor takes to decrease. Capacitors hold voltage for a little amount of time, and the bulb is using that power. So every time you use something with a capacitor or anything, you always discharge it. And I've had experiences already, like in my past videos. So yeah, let me just click stop, reset, and if I click run, no volts, right? Let's delete this line. Let's connect this line here. Connect this there. Wrong way. Delete this. Okay. Put this here. What will happen if I connect this? Click stop, reset, run. Now that red means that it is heating up. This bulb is not rated for that much. Anything red is not good. So let's delete this line. Boom. Current running through. Let's connect this back here. Ignore the bulb, it's just frozen. Reset. Now green. See how that path gets red? I think that because I didn't set this enough. Hold on. Did I set this wrong? Hold on. Did I put this wrong side by accident? Oh yeah, I did. I'm such an idiot. So you can see how the capacitor is slowly being charged. If I click edit and okay, hold on, wrong thing. The capacitance is 100. Why is it 100? Let's set this to 8 volts. So it is charging to 8 volts now. If I set this correctly, it should stop at exact 8 volts. Let me see. It is not. Interesting. But that's okay. It is a capacitor. It tends to happen. 18 volts. Okay. Now I understand. Now I understand. Okay. 20. Okay, I understand now. So 20 is the safest voltage it have. If it's rated 6 volts, when the rated voltage is like 10 or 15, anything over 15 will blow it up. Anything 8, like 9 or and over, but under 15 will heat it up slowly and burn it. So yeah, always check your capacitor rating before using it. Now what would happen if I connect a normal capacitor? Let me just reset this. A non-polarized capacitor. Let me see. Pass to a door. There you go. 10. Let me try a 10 one. What? I said this correct. What are you talking about? We edit this real quick. We set the capacitance to like 9. Let's run the simulation. Oh wait. Touch this real quick. If you click reset and run, look how the voltage slowly rises. The capacitor is being charged, and the light takes time to come on because it rated for over the voltage. The capacitor is charged right now. So once it reaches the voltage rated, it should glow. Supposed to. Why isn't it glowing? Delete, connect. Oh, there we go. Yes, they just shut up. So that is how you make a safe converter, a safe power supply. There's multiple ways to make this. So yeah, I will make a video on that in real life. I hope this video is helpful for anybody who wants to learn how to make a little electronic for themselves. So thanks so much for watching, everybody. Be sure to like, subscribe, and I'll see you